Hello students, good evening. Yesterday we discussed about qualitative analysis. Today we are going to discuss about quantitative analysis. Quantitative means we have to find the amount of that element, okay, or percentage of that element in the given organic compound. Okay, so qualitative means you have to identify that element, and quantitative means you have to calculate how much amount of element, okay, how much amount of the element is present, okay, or how much percentage of the element is present in the given organic compound. So remember once again, so quantitative means calculating the percentage of the element or calculating the amount of the element in a given organic compound. Okay, so quantitative analysis, quantitative analysis. Okay, so in this quantitative analysis, first one we will estimate the carbon or hydrogen. Estimation of carbon and hydrogen. How we can estimate the carbon and hydrogen in a given organic compound. Okay, so this here carbon and hydrogen are estimated by Liebig method. Okay, carbon and hydrogen are estimated by Liebig method. Okay, so Liebig method means here organic compound containing carbon and hydrogen on heating with CuO. Okay, carbon is converting into CO2 and hydrogen is converting into H2O. Carbon is converting into CO2 and hydrogen is converting into H2O. Okay, so by knowing the weights of CO2 and H2O, we can calculate the carbon and hydrogen percentage. Okay, so this CO2 is absorbed in KOH. This CO2 is absorbed in KOH, and this H2O is absorbed in anhydrous CaCl2. Okay, anhydrous CaCl2. So CO2 absorbed in KOH, H2O absorbed in CaCl2. So by absorbing in these two, we can calculate the weight of CO2 and the weight of H2O. So once the weight of CO2 and H2O calculated, then we can calculate the carbon percentage, hydrogen percentage. Okay, so here carbon percentage means in the CO2 how many carbons are there? Only one carbon. So one carbon atomic weight 12. CO2 molecular weight 44. CO2 molecular weight 44. So 12 by 44 into weight of CO2 by weight of organic compound into 100. This is the carbon percentage. In this way we can calculate the carbon percentage. Okay, so here already carbon percentage is equals to the CO2 one carbon atom only, so 12. CO2 molecular weight 44, so 12 by 44 into weight of CO2 by weight of organic compound. So if you know these two values, we can calculate the carbon percentage. Okay. Similarly, hydrogen percentage. Here in H2O, how many hydrogens are there? 2 hydrogens, so 2. One atom weight 1, 2 atoms weight 2. Okay, so 2 by H2O molecular weight 18. So 2 by 18 into weight of H2O by weight of organic compound into 100. Organic compound into 100. In this way, we can calculate the hydrogen percentage also. Okay. So in a given organic compound, carbon percentage, hydrogen percentage, we can calculate like this. By which method we can calculate Liebig method? In the Liebig method, hydrocarbon or carbon hydrogen containing organic compound is heating with cuprous oxide or copper 2 oxide. Okay, so in this case, what about you are getting CO2 and H2O? Okay, CO2 is absorbed in KOH, H2O is absorbed in CaCl2. So after absorbing these two, we can calculate the weights of CO2 and H2O later. Once CO2 and H2O weights you know means you can calculate the carbon and hydrogen percentages. This is about Liebig method estimation of carbon and hydrogen. Okay. Next, actually we have to discuss estimation of nitrogen. Okay. So estimation of nitrogen, to explain that we have to discuss some problems. After explaining the problems, if I explain that, then you will get easily. So that's why now I am skipping. I will do that in next video. So next part, next estimation, halogens. Estimation of halogens. Okay, estimation of halogens. How we can estimate the halogen? Okay, halogens are estimated by carriers method. Halogens are estimated by carriers method. Okay, so what is happening in the carriers method? Here, one carriers tube will be there. This is called carriers tube. First, here you have to add fuming HNO3. Okay, later, here organic compound already present. Organic compound present. To the organic compound, you have to add fuming HNO3 and AgNO3, ammonium silver nitrate. If these three added, okay, these three added, what is happening? If AgCl came, okay, AgCl weight you have to calculate. AgCl means what? White PPT. Okay, white PPT came means that is AgCl. So once this AgCl washed and dried, later weight of AgCl is calculated. Okay, so after getting the weight of AgCl, we can calculate the percentage of chlorine. Okay, so here how many Cl atoms are there? Only one Cl atom. One Cl atom means 35.5 by Ag atomic weight 108. Ag atomic weight 108, easily you can remember. So 108 plus 135.5, 143.5 into remaining, you can tell remaining same like these two, weight of CO2 by weight of organic compound, weight of H2 by weight of organic compound. Here also what you have to do? Weight of AgCl by weight of organic compound into 100. Okay, if suppose if AgBr came, how will get to know AgBr? Pale yellow. Okay, if pale yellow PPT came, okay, pale yellow PPT came, then that compound is a AgBr. Here also you have to wash, later you have to dry. After drying, you have to calculate the weight of AgBr. Once weight of AgBr we know, we can calculate the Br percentage, bromine percentage. So here Br atomic weight 80. So 80 by AgBr atomic weight 188. Okay, into next we can tell easily. Here AgCl written. Here what you have to write? AgBr you write. So weight of AgBr by, okay, weight of organic compound into 100. This way you can calculate the bromine percentage. Okay. Next one, if iodine is present, what will get then? AgI will get. AgI is a complete yellow PPT, complete yellow PPT. Okay, so it is yellow PPT means it is clear yellow PPT means iodine is present. Okay, so once this AgI weight calculated, then we can calculate the percentage of iodine. So iodine atomic weight 127. Okay, so 127 by AgI weight 235. Okay, 108 plus 127, 235 into weight of AgI by weight of organic compound into 100. Okay, so these formulas no need to by heart simply. If you know the weight of AgCl and weight of organic compound, or weight of that compound by weight of organic compound, these you know means you can easily calculate the percentage of chlorine, bromine, iodine. Okay, so this is about halogens. Next one, estimation of sulphur. Okay, next one is estimation of sulphur. How we can estimate sulphur? Here also carriers method. Okay, sulphur also can be estimated by carriers method. Okay, so in this carriers method, here also what you have to add? Fuming. To the this is the carriers tube. To the organic compound you have to add fuming HNO3. Later BaCl2. Okay, so to the sulfur containing compound, okay, to the sulfur containing compound, if it is treated with HNO3, okay, treated with HNO3, it is converted into H2SO4. Okay, this H2SO4 on reaction with BaCl2, it will give BaSO4, barium sulfate and HCl. Barium sulfate and HCl. So barium sulfate is a white precipitate. Okay, barium sulfate is a white precipitate. This white precipitate is washed, dried, later weight of BSO4 you have to calculate. So once weight of BSO4 calculated, then we can calculate the sulfur percentage. Okay, so sulfur atomic weight we know 32 and BSO4 atomic weight 233. Okay, BSO4 molecular weight 233 into later remaining same weight of this one by weight of organic compound, weight of BSO4 by weight of organic compound into 100. Okay, these formulas no need to by heart, easily you can get. Okay, this is the Carriers method, estimation of sulfur by Carriers method. Okay, next one now, the estimation of phosphorus. Estimation of phosphorus. Phosphorus can be estimated in two ways. Okay, phosphorus can be estimated in two ways. In one way, to the organic compound, if magnesia mixture added, magnesia mixture is added. Okay, to the organic compound, if magnesium mixture is added, the phosphorus present in the organic compound is converted into magnesium pyrophosphate. Okay, Mg2P2O7. So this is a this is precipitate. This is one precipitate. This precipitate weight also you have to calculate. Once you know the once you calculated the precipitate once you calculate the weight of Mg2P2O7. What is the name of magnesium pyrophosphate? Magnesium, okay, pyrophosphate. This is the name of this compound, magnesium pyrophosphate Mg2P2O7. Formula you to remember. Here, that weight you know means we can calculate the phosphorus percentage. How many phosphorus atoms? Two atoms. So one atom weight 31, two atoms weight 62. Okay, that Mg2P2O7 molecular weight is 222. Okay, into weight of Mg2P2O7 by weight of organic compound into 100. This is the of phosphorus. Okay, so in this way we can calculate the phosphorus percentage. For phosphorus, one more formula is there. Okay, one more way is there to identify the phosphorus percentage. Okay, so to the phosphorus containing organic compound, okay, if we add ammonium molybdate, okay, if you add ammonium molybdate NH3 twice, okay, NH3 twice, MOO4. This is added, this is ammonium molybdate, this is added, then what will get? Ammonium phosphomolybdate will get ammonium phosphomolybdate formula NH4 thrice PO4 12 MOO3. Okay, this is ammonium phosphomolybdate. This is ammonium phosphomolybdate. So this is yellow color precipitate. This weight is calculated. Then we can calculate the phosphorus percentage. Here, how many phosphorus atoms? Only one phosphorus atom. One phosphorus atom weight 31. So 31 by this full formula of molecular weight you have to remember 1877. Okay, so 31 by 1877 into weight of this ammonium phosphomolybdate. APM means ammonium phosphomolybdate by weight of organic compound into 100. Okay, by using this formula we can calculate the phosphorus percentage. Okay, next last one here, estimation of oxygen. Okay, so estimation of oxygen we can do in two different ways. Okay, so first way is if an organic compound is having CHO, okay, if an organic compound is having carbon, hydrogen, oxygen, okay, so by knowing the CO2 weight you can calculate carbon percentage. By knowing the H2O weight you can calculate the hydrogen percentage, and remaining what? Oxygen percentage. So from the 100 percentage, if you subtract carbon percentage and the hydrogen percentage, then what will get? Oxygen percentage you get when the organic compound is having only 3 elements. Suppose if the organic compound is having C H N O. Okay, if the organic compound is having these three elements, so these four elements, then you can calculate carbon percentage, okay, hydrogen percentage, and the nitrogen percentage. So after calculating these three, from the 100, if you subtract, okay, if you subtract these three, okay, then you get oxygen percentage. In this way, you can calculate oxygen percentage. This is one way. Sometimes, sometimes they will give other method. In that method, what you have to do? Organic compound on heating. Okay, organic compound on heating, it will give oxygen and a mixture of gases. Organic compound on heating gives oxygen and a mixture of gases. Okay, so this oxygen when passed through coke. Okay, this organic compound when passed through coke. Okay, coke means carbon. Then what will get? Carbon monoxide will get. Organic compound when passed through red hot coke will get carbon monoxide. Okay, so this carbon monoxide when passed through I2O5, iodine pentoxide, carbon monoxide when passed through I2O5, iodine pentoxide will get. So 5CO will combine with the I2O5, it will give 5 moles of CO2 and I2. 5 moles of CO2 and I2. So here by adding I2O5, iodine pentoxide, if you are getting CO2, okay, that is due to the presence of oxygen atom. Okay, okay. So there, here we will get a CO2. So by adding the I2O5, if you are getting CO2, means that CO2 is due to the presence of oxygen. So you can calculate the oxygen percentage. So oxygen percentage is equals to 16. Oxygen atom equates 16 by CO2 multiplied 44 into weight of CO2 by weight of organic compound into 100. So by using this formula, we can calculate the oxygen percentage. Okay. So now I explain the calculation of percentages of carbon, hydrogen, okay, halogens, phosphorus, sulphur, and oxygen. Okay. Next, what left? Only nitrogen left. The nitrogen estimation I will explain in the next video. Why? Because that nitrogen estimation, by solving the problems only, you can understand. Okay, right. Thank you.